Okay, this section on domain and range. You need to learn, first of all, what those two words mean. And then you have to be able to actually find the domain and the range for a relationship between two quantities. So I'm not going to write down, dictionary or textbook definitions of these right now. I want to use a situation that we're already familiar with so that it's easier so we don't have to struggle with the situation. The situation is, let's remember this Ferris wheel when we drew a graph of the Ferris wheel. And it took us a little while to come up with a graph, but eventually it seems like everybody came up with this graph. Okay, so first of all, there's the Ferris wheel. And there's some axes to draw the graph on. So the person going around here, they start at the bottom. And as they go around, their height goes up and down. Remember, this was time and this was height when we did this. Time and height. And they started, it went up, and it went down, and it went up, and it went down, depending on how many times around the Ferris wheel they went. So let's say they just kept going here without stopping forever and all of eternity. So we'll put an arrow on the end there to say it keeps going. The words domain and range refer to possible values for each of the variables in the situation. Domain refers to possible values of this, whatever is the independent variable. I'm going to write it first how people seem to remember it. They just remember it as possible x values, even though here the variable's not x. Or in this case, this one am I doing? This case, t values. Whatever the independent variable is, okay? Independent. And the other thing that's there, range, let's just shrink that down a bit because I'm going to run out of room. The range is values of the dependent variable, this, whatever's on this axis. Okay, so we can put that down too. And a lot of people, again, remember it as possible y values because they always think of the horizontal as x and the vertical as y, even if they're actually different variables, right? Or here it's h values, right? Or in other words, the dependent variable. Okay? So range possible y values or whatever the dependent variable is. Domain possible x values, whatever the independent variable is. Maybe we'll move this over so we can not get it. It's too crowded there. Move that over there. Now, we need some numbers. I don't know if you remember from the situation. Time started at 0, and then the height started at, I think it was something like, I mean, you all measured maybe slightly different numbers, but let's say it went from 8 up to here, 48, just arbitrarily. Let's say that that's what it was. Move that h. Okay, so there's our relationship for the person going around the Ferris wheel. There's a lot of different ways to express domain and range. You can, if you don't like what I'm saying here or you want another opinion or another source, you could go to the textbook and look on those pages. It has a nice little summary of all these things. But for now, I'm going to just write you my own summary down here. Ways to express domain and range. The simplest way is with words or verbally. Verbally, in case you don't know what the word verbally means, I'm going to put with words. I'm going to do the domain for you, and then I'm going to ask you to do the range after to check that you're okay with what we're doing. What kind of numbers is time allowed to be here? What kind of times are represented in this situation? What kind of values can t be here? Because a lot of different things are different, right? In this situation, is 1 second a possible time? Is 2.5 seconds a possible time? Both of those are okay, right? Can you have 3.2679 seconds? You can't? You probably can at some point. Like, she's continuously going around the Ferris wheel, right? She doesn't only exist when it's 0 seconds and 1 second and 2 seconds, right? She's on the Ferris wheel at every possible time after 0, right? This thing is a continuous curve. When you guys drew it first, you only put dots. I notice a lot of you put a dot here and a dot here and a dot here. But is that how she actually, what would that mean? If that's how our graph was without this, what would that mean? She instantly teleports from the bottom to the middle to the top to the middle to the bottom. That's not how it works, right? She continuously rides the Ferris wheel. So instead of a bunch of individual dots, it was a curve that we had, right? It was up to the top, down to the bottom. This is really not drawn very well because it should be symmetric, but we'll go with that, right? She continuously rides there. Time can be any value greater than or equal to what? What's the lowest time? What's the smallest time that's represented there? She starts at 0, right? So times can be any number. Now, when I say number, we need to be specific about this. If you learned your sets of numbers, it could be any real number greater than or equal to 0. Okay, so that's with words, how you can express the domain. Okay, the possible values. I know that seems intuitively obvious in the situation, but you can't have negative times, right? Okay, another good way to show it is you can use a number line, which is graphically. Number line. Graphically just means with some kind of a graphics, right? Picture. If you want to show this on a number line, let's put a number line here first. Okay, so there's a line we can use, and all we want to say is starts at 0 and goes up here with numbers like this. You don't have to put too many numbers on there, but we want to show that which ones it is, which ones it isn't. I'm assuming you've done number lines before. You should have. If we want to say it's greater than or equal to 0, start at 0 and go this direction here, right? So if you put a thick arrow saying it goes this way, and it keeps going, right? We're assuming she never stops. I know that's kind of a silly situation that she just rides forever, but that's what the number line would look like. Some other ways you can show this. You can show this algebraically, which is like symbols, you know, mathematical symbols. The way you can show it algebraically, I'm going to have to write, hopefully you're being able to fit it in on your page, but you can basically just say this, because I know you know how to say this mathematically. How do you show symbols for this? Greater than or equal to 0. Well, you say something like this, right? You say, the variable is t here. You say, time is greater than or equal to 0. Which way do you put the symbol in here if you want to say greater than or equal to? So the big end is at the t, right? Greater than or equal to. You have to be able to read these things both ways. Don't memorize that that's a greater than symbol. It depends which way you read it. This says, if you read that way, time is greater than 0 or equal to 0. If you read this way, right to left, it says 0 is less than or equal to time. That's going to be important to read it both ways. That's algebraically. Now, just to further confuse things here, what you have to think about when you look at algebraically is something called set notation. And this is the one that always people in grade 10 seem to get confused about. Mathematically, when you say this, we haven't said what kind of numbers it can be, because often when you use the word number, you refer to different things. So I'm going to take a slight break from this for a second here and talk about a different situation that you will relate to. Okay, so we'll just go down here to a blank slate here. I'm sure you've been asked before to pick a number between 1 and 10, right? Pick a number between 1 and 10. Somebody's asked you that before? Have you ever said to the person, or a number like 3.2 or pi or square root of 8 or something like that? Have you ever picked any of those numbers? I know that your friend would be very impressed if you picked that, or they'd think maybe you're kind of a math nerd or something, but technically all of those numbers are between 1 and 10, right? But what is the person implying or assume you understand when they say pick a number? What kind of number do they mean? What do they mean? A whole number, right? So nobody ever says pick a whole number between 1 and 10, but that's what they imply. If you were saying this mathematically, if we were to use a number line, it wouldn't look like, if we wanted to say number between 1 and 10, if this is 1 here and this is 10 here, it wouldn't be like this where you have a solid line here and then this. Because what would that be showing if you showed a number line like that? If you filled it in all the way between 1 and 10, you're saying every single number in between there, right? That's not what we want. What does the person actually mean when they say number between 1 and 10? You can pick 1 or 2. It's going to be a series of dots, right? This is what it would actually look like here. I'm going to run out of room for 10, but you get the idea, right? 5, 6, 7. If you wanted to show it on a number line, that's how you'd have to do it. And I have to fix my number line, which this is in the way. And so on, right? There's 8, 9, 10. That's how you'd show it with a number line. It doesn't include these kind of numbers if you mean that. If you want to show it with symbols, you can't just say some number. So if we're using n for number, incidentally, how do I show it with inequalities? How do I show it that it's, because what I had before here, there was one condition on it. It had to be greater than 0. Here I kind of need 2 conditions on it. When I say a number between 1 and 10, how do I use greater than, less than symbols to show that? Well, doesn't it have to be greater than or equal to 1, but also less than or equal to 10? Has to be between those two? The way you show it with symbols is, there's 2 conditions. You need what's called a double inequality. So basically the easiest way is put the n here, put the upper number there and the lower number there, and then put inequality signs in between. I'm going to put the upper one first because people find that one easier. It has to be less than or equal to 10. So I'm going to put the symbol this way. Do you see why I go that way? But it has to be greater than or equal to 1. Which way do we have to put the symbol in here to make it greater than or equal to 1? Which thing's bigger, 1 or the number you pick? Which one can be bigger? The number can be bigger, so it's got to go this way. This is something that a lot of people really struggle with, is setting up a double inequality. Because I think after all these years I finally figured it out. Because when you say this, you read from the middle. You say n has to be bigger than or equal to 1. You read that direction. But then when you're reading the other way, you're saying n has to be smaller than or equal to 10. So in their mind, they're thinking greater than or equal to and then less than or equal to. They think the symbols have to be opposite directions. Do you notice that they're pointing exactly the same way? They're pointing the same way, but you read this way for the first one and this way for the second one. When you read them the other opposite ways, they mean different things. That's a double inequality. The problem is if you just say this inequality, it doesn't imply just those dots. It implies every single number in between there, like the thing filled in. So in math, it's important for us to specify what kind of numbers we mean. If we mean whole numbers, and again, mathematicians are really lazy here. So they invent symbols way up here. If you go back to this, I took a screenshot of it and put it in your booklet here. Mathematicians invent symbols here. Symbols used for whole numbers, W, that makes sense. Natural numbers, N, that makes sense. I for integers, that makes sense. Here's the one that doesn't make sense. Well, this one makes sense, R for real numbers. But then look what somebody did for rational numbers and for irrational numbers. Does that make sense here for you, these two symbols, Q and Q with a line on top of it? Why did they pick Q for rational numbers? Why didn't they pick R? Because they already used it for real numbers, so they needed something else. I have no idea why they picked Q. Somebody could maybe research that. If Q is rational numbers, it makes sense why Q with the line on top, Q bar, not Q. This line on top of this means not whatever's underneath it. So that means not a rational number. Anyways, the symbol we need for what we're doing below is this W here. We want to say it's a whole number first. If we want to say it's a whole number, here's how you say this mathematically. If n is the variable you're using, you say n, there's a new symbol you've never seen before. It looks like this. It's like a half circle with a line down the middle. What that symbol means is an element of. I think you should write all of this stuff down somewhere on your page so you have something for reference when you look back on it. So this is the number. This thing is an element of, and what was the letter for whole numbers up above there? Capital W. Now I know what you're thinking here, and I know that this degenerates because nobody ever learns what this symbol means. Can you imagine if you never learned this, what this symbol means in grade 3 or whenever you learned this symbol? What does this symbol mean? Equal. When you first learn it, you don't know what it means, and you think it's just two horizontal lines. Can you imagine if right up to this point in your life you still said, if you saw this statement, you said for two horizontal lines, 2 plus, or 2, and you didn't learn this symbol either, 2 vertical line, horizontal line, or cross, or whatever, 2. You know obviously that this is equals and this is plus, right? Please learn that this symbol means is an element of, because otherwise you're going to be saying, oh, look, it says new. It doesn't say new. Okay, this is not an E. I would even put that down here. This means is an element of. It's not an E. Because what happens is people do this. They think it's an E and they draw it like an E. It's not an E. Okay, it's not an E. It's a symbol that means is an element of. It's a half circle and a line. You could also say it, you could say is an element of, or it belongs to, or whatever. Okay, now I know that this is a long time in developing here, but this is one of the toughest things for people in this particular unit. Now, what we want to do is combine this into one sentence here. One mathematical sentence. And the way you do that mathematically is you say, first I'm going to tell you what group this belongs to. So I'm going to put that first. And then I'm going to put this, that it has to be between 1 and 10. Now you could put a lot of things in between those so that they don't run together. Just like in English you put periods and commas and colons and all that kind of stuff. In math they put a symbol that looks like this, a vertical line. This symbol means, and I'm going to move this is an element of over here with my this, right? Is an element of was this. This symbol right here, this vertical line means such that. Okay, so let's read this one step at a time here. Your number is an element of. The whole numbers, let's write that over somewhere else here. Whole numbers. I would write this down somewhere so you have something to refer back to. Running out of highlighter colors here. Such that, and all of this thing, we're going to have to go to a fifth highlighter here. Let me get that. So this thing right here, that's the condition, and you can read that, right? Your number is between 1 and 10. If you read that thing all together, and then the only other thing that people do is they put some strange looking curly brackets around it to say it's one big sentence altogether. So again, it says your number belongs to or is an element of the whole numbers such that that number is between 1 and 10, including those numbers. Okay? That's called set notation. I know, again, that's a long time in developing, but this is the one thing that people struggle with in this unit. If we were going to do set notation for our previous situation here, for this thing, set notation, I almost have set notation already here because I have this already. I have the condition. I just need the part at the beginning here. All I need to do is put this part on here and say, what type of number can this be? For the Ferris wheel, is it just whole numbers it can be, that times can be? What kind of numbers can they be out of that list? Let's go back here. What kind of numbers can they be? They're certainly not just whole numbers. She's not teleporting, right? We already talked about that. What type of numbers is it? Anything. It could be, like, technically, if she travels around this Ferris wheel, she could be at pi seconds at some point, right? At some point, if she travels from 3 to 4 continuously, even though this is a weird number, she hits this point, she hits every possible number. It's a real number. It could be 3.1415, all that, right? It could be square root of 8, whatever that is, 2 point, whatever that is, I don't know. It could be any one of those numbers. It's any real number. It's not just rational numbers. It's both of these together, rational, irrational. So, again, in this situation, obviously, that you kind of just assume that, but we should say, if we're using time here, we should say time is an element of the real numbers. Okay? And we should put these squiggly brackets around it. I guarantee you on your exam at the end of the year, you'll be asked to put things in various representations here. Please don't think again that this doesn't say ter, okay? It doesn't say Terry, right? You got to know the symbols. It's not hard once you know the symbols. I want to tell you a very quick short story about an aunt of mine. She, when she was younger, had Italian spoken in her house. But not that much, and obviously she learned English eventually, or she learned English as her first language, but there was some Italian spoke. When she was old, she traveled to Italy. Okay, she didn't really speak Italian very well anymore. She was on the train. She was traveling with my dad, actually, and there was this little kid in the next seat who was speaking Italian fluently, right? And she said to my dad, "Oh, listen to how well she speaks Italian." And if you grow up with Italian, is it hard? No, it's not, right? Because you have learned it. If you haven't learned Italian and something's written in Italian, it looks like a bunch of gibberish, right? If you know what the words mean, it's easy. It's the same thing here, right? If you learn what these symbols mean, this is not going to be hard. If you don't take the time to learn the symbols, it's going to look like a bunch of gibberish. You're going to be working on that exam at the end of the year. You're going to say, I have no clue what that means. Okay? So take the time to figure it out. I know this is long already, but there's one more way you need to learn here. Okay? So I am going to cheat and make more space. I know you don't have that luxury. Too bad for you. Page extender tool here. The last way here is sort of another algebraic way. But I'm going to give it a different title. I'm going to call it. I have invented this name. No, it's called interval notation. It's another. I mean, it's with symbols again. It's not something different than that. Interval notation here is because mathematicians are very lazy always, right? They didn't go into English or socials or anything like that because it's way too much writing. That's why they went into math, because you can condense it down to very little writing. But even mathematicians say, oh, this is way too much writing. I don't want to draw a number line and put the numbers. It's going to take forever to make that number line. So they invented something called interval notation. They said, all we really care about here is where does it start, where does it end, and do you include the endpoints or not? That's all they care about. Where does it start, where does it end, and do you include the endpoints? So interval notation, if you're doing it for this one, you'd say it starts at 0, so start value or point, and we need an end value here. In this situation, is there an end value? Is there an ending value? If we assume she rides forever, the end value is what? Infinity? Do you know a symbol for infinity? Because you should learn it if you don't already know it. Sideways 8? Exactly. I am seriously challenged in drawing them. That's actually pretty good for me, but it's a sideways 8. If you actually, you know I don't know, you maybe have never seen and probably never seen the Ma10 flag, you know, the Ma10 nation in Canada. The Ma10 flag has an infinity symbol on it, because I think it symbolizes they will always be, in existence, and no one can ever take that away, something along those lines. But I know it's dumb to put that the end point is infinity, because is infinity a point that you can get to? It's not. But for interval notation, you always need a start value and an end value. And you put a comma in between. And then the other thing I said is, interval notation, do we include the endpoints or not? The way we had our number line there was 0. I put a solid dot there. Why did I put a solid dot at, Why did I put a solid dot at 0? To say it includes that. If I didn't want to include 0, I'd put an open dot there and say this way, right? But the fact that it was a solid dot, it includes that. The way you show that with interval notation is you put a square bracket. So I'm going to put here, square bracket means includes the endpoint. Does include endpoint. That's a crazy symbol I just invented. D and a P stuck together. Okay, it does include the endpoint. Can we include infinity? Can infinity be a point you get to? Can we draw here? Here's infinity. Okay, I know if you have ever seen Toy Story, to infinity and beyond, there's no beyond, right? There's no beyond. You can't put a dot here, because then this is infinity plus 1, right? I mean, there's no such thing. There's no dot for infinity. So you got to not, when you write interval notation, you put a round bracket if it doesn't include that. Infinity is not a point that you can include. So we're going to put here round bracket. I know one's called a parentheses and one's called a bracket and all that, but I'm just going to say round bracket, square bracket. Round bracket means doesn't include endpoint. That's interval notation. This is the lazy man's way or lazy woman's way to draw that number line, or to describe all the numbers greater than or equal to 0. Okay? There's a bunch of different ways to represent domain and range. I know it's really long. That takes a while to develop, right? Now actually, as I said right at the beginning, if I can go back there, if everybody's got that, I told you about domain and range, but which one did we talk about here? We just talked about the domain. Here is your quick little self-check here right now. The self-check is I want you to express the range for this situation using those 4 different ways. So I want you to express the range. Remember, range is the possible dependent values, the heights in this case. Okay? Find some space somewhere and express the range. I'm going to do it up here because then I can see the picture really easily. So we want all those 4 ways: words, number line, set notation, and interval notation. Okay? You do that right now. I'm going to pause the video and give you some answers in a bit. Okay, so really quickly here, with words, two different ways you can say it. I'll write one of them. You can say any real number greater than or equal to, any real number greater than or equal to 8, but less than or equal to, less than or equal to 48. Okay? On a number line, if you draw a really quick number line here, 8 is here. It includes 8, so you put a solid dot. It includes 48. You put a solid dot, and you fill it in. If it didn't include the endpoints, you would just put hollow dots there. Let's keep that. If you're doing interval notation, you're including the 8 and the 48, so you put square bracket, that, start point, end point, square bracket, saying it includes it. Square bracket, same as solid filled in dot, okay? Set notation is the hard one. Essentially what you want, first you can, when you write it, you're going to say, if this is H, you say H has to be a, what kind of number is it? Real number. Such that it's between 8 and 48. Here's how I recommend you try to write this double inequality to avoid problems. Put the H down, put the upper limit to the right, put the lower limit to the left, and then draw the symbol so that the things are the right way. They're always going to point the same way like that. It's bigger than 48, but less than, or sorry, bigger than 8, but less than 48. And then the only other thing you have to do to complete that is put the weird squiggly brackets. Okay? That's writing it those 4 different ways. Okay? I realize that was a long time. Okay? Very long, but hopefully you're going to be okay with this now. Okay? So do some of the practice and you'll be good, I think.